In this lesson, we're going to examine where we can use trigonometry in situations that involve multiple triangles. And the big idea here is, if you have multiple triangles and they share something, they share sides, they share angles, then it's often handy to figure out those shared sides because you can use that value in multiple spots. And there's only 3 examples, so it's a really quick lesson, but I want you a chance to practice some things. And this is a good chance of practicing our SOHCAHTOA. So let's write that down right at the top first, so we know what we're talking about here. Okay, I want to find x. The problem with finding x is in this top triangle, there's only one known thing. In order to use SOHCAHTOA, I need to know 2 things. So I can't solve directly for x. However, if I look at the bottom triangle, it has 2 known things. It's also right angled, so SOHCAHTOA is handy. And using these 2 triangles, we notice that there's a shared side, in particular this side up here. So if I can solve for that side in the red triangle, I know it for the blue triangle, and I can use it to solve for x. So let's label our sides according to our angle that we're given. This would be my opposite. This would be the hypotenuse. That tells me I'm using sine. Okay, make sure when you're doing this up your calculator is in degrees, okay? So we're going to do the sine of the angle we use, which is 61, equals y over 15. Okay, we can cross multiply. 1 times y makes y. 15 times sine 61 is 15 sine 61. Into our calculator we go, and we get 13.12. Well, now that I know that, I can restart this problem using this angle. So this would be my opposite. This would be my adjacent. That tells me to use tan. So the tan of our angle was 19. Our opposite was x. Our adjacent was 13.12. Again, we can cross multiply and solve this. 1 times x is x. So 13.12 times the tan of 19 will give us our answer. And hopefully you guys got 4.52. Okay, so we had to solve a shared side to be able to use it to do the next triangle. And when you have the diagram, it's not too bad. In this situation, however, we don't have the diagram. So we have to interpret the problem. From the roof of a small building, the angle of elevation to the roof of a nearby building is 15. Angle of depression to the base of the same nearby building is 37. The buildings are 65 meters apart. How tall are the buildings? So in this situation, we have to imagine ourselves on top of the roof of the small building. That's what we're talking about. Okay. If we were looking straight off this roof of that small building, we have a straight line, and we know they're 65 meters apart. It then talks about the angle of elevation. The angle of elevation goes from the horizontal line, which we just drew, upwards. So if we looked up at the roof, the angle we looked at right there is 15 degrees. If we talk about the angle of depression next, again, we're still in the building, and we're looking down at the base. The angle we measure is inside. It's 37. And we want to know how tall the buildings are. Well, I can do that if I think of this as 1, 2 separate triangles. And really, if I think of this as this being an x and this being a y, I can figure out how tall that building is if I simply add them together. Yeah, so let's do the math. The math is, well, based on the angle that I'm using, this would be my opposite, and this would be my adjacent. If I look at the bottom triangle, I actually have the same situation, an opposite and an adjacent. So I'm going to do the same problem twice, just using different angles. So the tan of 15 is x over 65, and the tan of 37 equals y over 65. In both cases, I'm going to cross multiply. 1 times x makes x, and 65 tan 15. Well, I can put that in my calculator, and I should get 17.42. Same thing for the next one. Y equals 65 tan 37. That comes out to 48.98. Okay, so the question was, what are the buildings? Well, the small building is, well, the small building is the same height as y from here. Has to be the same as from over here. So it's 48.98 meters tall. The taller building is both x and y together. And it goes from y all the way up to x. If I add those two values together, we get 66.4 meters tall. And we solved it. It had two separate triangles. In this case, we had to take those values and add them together. They had a shared side, that's 65, so we used it in both problems. And we did the same math in both problems. Okay, last one. A tree is growing on top of a cliff. From a point 18 meters away from the bottom of the cliff, I'm going to turn the cliff just so it looks a little bit more obvious here, okay? From a point 18 meters away from the bottom of the cliff, the angle of elevation at the top of the tree is 18, and the angle of elevation at the top of the cliff is 16. So we're over here. If we look straight, we'd be looking at the bottom of the cliff, but we're not. We're looking upwards, and the angle of elevation to the top of the tree. So this angle right here is 18. We're also looking up at the top of the cliff. Top of the cliff, angle of elevation is 16. And if I think about this as being right angled, I've got two problems again. Now this one's a little bit trickier. Okay, so I'm actually going to separate my diagrams. I'm hoping you guys would agree. The very first line we drew with the 18 would go all the way to the top of the tree. Okay. And it also said that we are 18 meters away from the bottom of the cliff. So I forgot to put that in the diagram there. Let's put this in. Okay. Okay, so this is the tree plus the cliff. The second diagram, which is just the tree, is still 18 meters away, but the angle is only 16 degrees. Okay. The questions I'm being asked are, how tall is the tree and how tall is the cliff? Well, I can figure these out by using trigonometry again, SOHCAHTOA. So in both situations, I have an opposite and an adjacent. An opposite and an adjacent, which means I'm using tan either way. And it's actually easier to figure out the tree one first, because I can see in this diagram right here that if I do the tan of 16 equals the opposite, so that's the x over 18. I can cross multiply. I've got 18, 10, 16. And I put that in my calculator, I get 5.16. There's my cliff. If I do the other one, so that would be this one now, and do the exact same math, tan of 18 equals x over 18. Cross multiply. 18, 10, 18. I get an answer of 5.85. Now what is this? What have we figured out? Well, my x in my first diagram was the cliff. In my second diagram, this was the cliff plus the tree. So if I want to know how tall the cliff is, well, I got that answer, right? That was the first one. Done, right there. If I want to know how tall the second answer is, the tree itself, just the tree, okay, I can say that my tree would equal the 5.85, that's the cliff and the tree, minus the cliff. The difference between them has to be the tree that's sitting on top. So it must be 0.69 meters. So again, we had some shared things going on there. They both have the 18 at the bottom, and they actually both shared something on the far side. They had the cliff involved in both of those. Sometimes we have to add values together. In this case, we had to subtract. We have to think of that being two separate things on the right-hand side. Okay, today is really a day we want to practice some things. Okay, so we have a little assignment that came with it. It's on the website. We print it off, try it, and we're going to hand that in.